case will definitely be what? I said that once it is what? An element, the number of protons is definitely going to be number of neutrons. It is when you have it as an ion that number of electrons will be affected. So automatically, number of electrons will also be 27. So if you want to arrange it respectively to be what? 27, 33, and 27. So we'll go to our option and see the one that fits this. Option A states that option A we have 60, 33. We don't need to even look at others since the first one is 60. Option B 27, 33, 33. That one is also wrong. Option C 33, 27, 27. That one is also wrong. Option D 27, 33, and 27. So option D would be the correct answer for this question. Question 7. We have I1. They gave us what? Evaporation. I2. We have sublimation. I3. We have diffusion. In I4, we have Brownian motion. So in this situation, we are asked that which of the above can correctly be listed as the evidences for the particulate nature of matter. In this situation, we have this one is testing particulate nature of matter. This one is also testing particulate nature of matter. Diffusion also talks about that. Then Brownian motion. Automatically, the answer should be 1. The answer will definitely be 1, 2, 3, and 4. So we'll go to our option and see the one that correlates with that. A, 1 and 3, no. B, 2 and 4. 2 and 4, no. C, 1, 2 and 3 only. 1, 2 and 3 only, no. D, 1, 2, 3 and 4. So it's option D. The answer to that very question is D. Then the number 8. If the elements X and Y have atomic numbers 11 and 17 respectively, what type of bond can they form? Though we are going to talk about this more in the next topic, but here with our residual knowledge, we have X to have atomic number of 11, then Y to have 17. By mere looking at this one, you will have what? 281. So definitely, it will definitely be what? It will be a metal because it will lose this electron to become what? Positively charged or donate it. Then this one is 287. That means because every element or every element is working towards what? Stability. And you can only have stability in the duplet state or octet state. In the duplet state, you have them as 2. While in the octet state, you have them as 8. So this one will need to donate this electron to become what? 28. That is when you have X plus, then it's now what? 28. So definitely it is a metal. This one in this regard, we need to accept electron to become 288. In that state, it will be Y minus. Take note. Y minus 1 or minus. So in that situation, that means this one is a metal, this one is a non-metal. So which type of bonding do you have? We have an interplay between a metal and a non-metal. It is definitely what? Ionic or electrovalent bond. Because in ionic or electrovalent bond, you have a transfer of electron from an atom which is what? Metallic to another atom which is a non-metal. So in our option, we have option A, dative, option B, covalent, option C, ionic, option D, metallic. So the option C is the correct answer here because it's an interplay between a metal and a non-metal. So the option C is the answer to question 8.
let's talk about the kinetic theory of matter and gas laws, which we have discussed in the previous lesson. Actually, you have to talk about kinetic theory of matter and gas laws. Then we need to admit the fact that we have real gases and ideal gases, then the deviation, then the change of state. So the deviation of the real gases from the ideal gas is simply on the note that real gases deviate from ideal gas in that they occupy space and there are forces of attraction between them. That is between them. That is why when you have them in a containing vessel, they tend to move about randomly without a preferred pattern, striking the wall of the container and rebound. So it is on that note that we can deduce that real gases will definitely deviate from ideal gas simply because they occupy what? Space. Because they are matter and there are forces of attraction between them. So automatically the forces of attraction is between them. Unlike that light poles tends to repel while light poles attract. So there are forces of attraction between them. Then let's talk about change of state. The major factor that brings about the change of state is definitely temperature. It's temperature that brings about the change of state. So when you have increase in temperature, then you'll be talking about heating. Increase in temperature, you're talking about heating. Then decrease in temperature, you'll be talking about cooling. When particles are heated, they tend to acquire kinetic energy and they vibrate faster and move faster. When there is a decrease in temperature, automatically they becomes less energetic simply because the kinetic energy has been reduced. So there is a comparison between the three states of matter, which we know as what? Solids, liquids, and gases. Then on this note, we know simply that we have our gases. Let's say these are our gases. Then let's have our liquid here. Our liquid. Let's have our liquid here. This is our liquid. Then let's have our solid here. Solid. Let's have our solid here. Now, we can establish a fundamental comparison between these three states of matter. The first thing that we need to know, as far as I want to describe these states before I now talk about how one can link to the other by the processes involved. Now, when we talk about solid, in the solid state, the particles are held in fixed position. That means they can neither move nor translate. And what brings about their fixed position is as a result of what? Strong intermolecular forces of attraction. So in the case of solid, they cannot move about. They occupy, they have a definite shape. They have a definite shape and a definite volume. So that is what we want to know about solid. But in the liquid state, liquid this time around, at this point, the kinetic there is little or no kinetic forces of what? Attraction. In the liquid state, the particles have acquired kinetic energy. So in that situation, they can now move, they can translate. The first thing you need to know about liquid is that they can translate. And another thing you need to know is that they assume the shape of the containing vessel. So what am I trying to say? That is, if they are in a triangular vessel, they will be in form of a triangle. If they are in a rectangular vessel, they will be in form of what? A rectangle. And if they are a square vessel, they will be in form of a square. So they assume the shape of the containing vessel. In the case of liquid,